Okay.
So what I wanted to say, guys, is we do have 8 presenters scheduled, but right now we don't have 2 of those people present. And so in theory, we could go, provided depending on what happens with those 2 missing presenters, we could go just a little bit longer than 15 minutes per. As far as like up to 20 minutes. Now that depends on if we get those other presenters, but we'll just kind of gauge things. So I'll ask Dan, at least initially, to just target the 15-minute time frame, which includes like a Q&A segment, if you wish to include that with your main presentation. So, and I'll turn it back over to you, Lloyd.
Okay, so I'd like to say welcome everyone to the Robothon exhibition for 2022. And yep, I think Donna, you already covered it pretty much. We've got 8 presenters on queued up, 6 are here apparently. So we're gonna move right along and we'll do probably about 3 presenters, have about a 15-minute break, do 3 more presenters, have about another 15-minute break and kind of go from there. With that, I'm going to get us started. Let's see. And how do I keep getting renamed Supreme Leader? I don't know how that's going. Okay, anyway, with that, Dan, you are first, and this is Machine Learning Dog Walk in Unity. So go for it.
Hello, everybody. So as you said, my name is Dan Roy. I work for, I started a little company about 11 years ago called Marginally Clever Robots. You can find out more at this first link with the channels, or join us on our Discord where we talk about all kinds of robotics things, or then of course the Instagram and the YouTubes. I don't have enough followers yet to get a short YouTube URL, so pause the video and copy that down if you need to. I'm best known more recently for the Michelangelo, which is a robot that hangs on a wall and draws pictures. And this is a shot from the app that has converted a picture of Ana de Armas. Here are some of the other robots you probably don't know about. This is in my library of dead machines. You can see I did my own 3D printers. I have quite the obsession with robot arms and Stewart platforms. Yes, many robot arms and quite a bit of filament used up. If anyone comes up with a good filament recycler, please let me know. Here are some of those drawing robots that I mentioned. The vertical plotter, a tabletop version that you may have seen in a version of it at the San Mateo Maker Fair. It was called the, what is it called there? It doesn't matter. Czar plotter maybe? Yeah. I also built things like, this was a jigsaw solving robot that picks up puzzle pieces and moves them around. This was 5 years before our recent YouTube hit, and it was all connected up to Twitch, so kids could yell on the internet to make it go. These are dog parts from some of the people in my community designing their own boards, and that brings me around to, like, this is my first robotic crab. So it had 6 legs, which is a little bit easier than 4 because you've always got 3 on the ground. To make this crab go, back in the day, I started writing an app called Robot Overlord, which is in Java, and it simulates any number of robots virtually, because building them in VR first is way cheaper than doing them. Oh, geez, I haven't been showing my camera feed. My apologies. I got to back all the way up here. There we go. Right. Here's some links. Moving on. Here's the Ana de Armas in the thing. Here's some robots. Let's get me out of the way. Dead robots, Stewart platforms up here. More robot arms, drawing robots.
Hey, Dan.
Yes?
I don't know if I'm doing something wrong. All I'm seeing is Jim's screen. I don't see anything else.
Yeah, I think I'm seeing the same thing, and I thought it was on my end. Jim?
It's probably focusing on Jim because he's not muted.
Oh, okay.
Okay, let me mute Jim.
If I share screen, maybe that will work.
Yeah, go
No,
ahead.
probably won't because my virtual camera is running anyways.
Well, I think Jim is doing a screen share right now. Yes.
Yeah. So
Yeah,
I
I think that's what's going on. Jim, could you stop sharing your screen?
Steve, can't you pick whose video is pinned in order to be the main thing for the presentation?
I think so.
So
There we go. That got it.
Did you get it fixed?
I think so. So is everybody seeing Dan now and his screen?
No, I'm still seeing Jim's little bot with the e-stop on the top.
because
Yeah,
Zoom
that was my
opens two
concern. That's
windows
why it
and
just
it's put the wrong one on top for you.
Whatever you did actually brought up the you know, there we go, a grid of everybody in the meeting, but not the video feed.
It shows Jim's screen. It says
There
you
we
were
go.
wearing Jim's screen.
What I've got two panels showing
There,
up.
I got it. I got
Oh,
it.
okay.
There it is. There it is.
So we're good to go here now?
Except I'm not up here for some reason. He said I was casting to the screen and I'm here, but I'm not there.
Okay, go for it again, Dan. Sorry about all that. I think we got it sorted out now.
We could just take the next door and we have to change it.
I'm ready. I can go.
I'm ready when you are. All right. Hi, guys. My name's Dan, marginallyclever.com. I've been making robots now for about 11 years. You can find most of my stuff at the links you see here. For example, there's the YouTube link. Pause it and copy that down later, or just search my name. So I'm best known these days for the Michelangelo robot, which hangs on a wall and draws pictures like the ones you see back here, or the one on the screen with the app. My goal this year, my New Year's resolution was to collaborate with as many people as possible. So I'm looking for anyone who's interested in the projects I've worked on in the hopes that we can work together to achieve even more. Yes. So here's a few of the robots you may not know about. These are some of my dead machines. I've got up here the robot dog that I'm going to bring up in a minute. Line followers, Delta robots, Stewart platforms, robot arms of many, many types. And of course, the ubiquitous giant box of wasted plastic. These are some of those versions of drawing robots that I mentioned before. And another one you may not have known was a robot that solves jigsaw puzzles and was connected up to Twitch so that by letting kids yell on the internet, they could collectively solve the puzzle. It was easier than writing AI because at the time I had not done any experiments with TensorFlow and image processing and all of that kind of stuff. That Discord community I mentioned is really active in dog type stuff like designing their own PCBs. And here's one that was in a box. Is my very first robot was a crab, a six-legged walker. 6 legs is pretty easy because it's always got 3 feet on the ground, which is wonderful for balance and locomotion. To the very first version of this robot, I built by first making a computer model and then simulating it. Because before, 20 years ago, I used to be a video game developer. So I took an empty video game world and I put my models in there and I made them move around. And I've done that ever since. The app is called Robot Overlord. It's in Java. You can download it and play with it, add your own machines if you like. And it was great for what it was at the time. More on that a little bit later. So yeah, the robot arms. This is one of my more recent robot arm models in 5 and 6 axis. Now, the talk is about dogs, so let's get to that, yes? Here is a model of a dog that I built in Robot Overlord. A guy in Korea whose name escapes me, I'm sorry, first built something called the Spot Spot Mini, based on the Spot from Boston Dynamics. And if I want to show that I too have built one of his open source designs. It has since been destroyed by some students I gave it to as a work project, but that's no hard feelings there. It was due for destruction. Test it to failure, I lose nothing. I suppose the real lesson there for people who aren't into robotics yet is that hardware is expensive. Hardware is hard. So again, doing it virtually is the easier way to get things done. Now, Robot Overlord was great. It did a lot of stuff, but it didn't have a physics engine. And I feel like if you're going to teach a robot dog to walk, the first thing you have to do is have a virtual world where they can fall over and make mistakes. Otherwise, they're never going to learn their lesson, right? So this was the first model of a dog that I built. Very, very straightforward. You'll notice the body is narrow and tall, unlike most of the designs that are out there, because I thought that this would make it more of a, like a lifting body in an airplane. This design, I hoped, would roll over more easily, almost always land on its side or on its belly. Yes. Some people said add a head to it. So the versions evolved, and pretty quickly I started getting results like this. I skipped over a bit because I didn't have a physics engine in my Java app, and there doesn't appear to be a straightforward Java engine. Somebody's mic is looping back. Because I didn't have a straightforward Java engine, I adopted the Unity system, the game engine for Unity, which has physics, which has models, which has textures, all this kind of stuff, and a huge community around it. So that was a kind of collaboration, just working with existing tech. I only have one lifetime, so I have to do what I can in the time available. As it happens, you can actually run many simulations simultaneously if you do it right. So these are some of the results that I was getting early on. I guess that GIF stopped itself automatically. Yeah. Try my best, right? Learning, what I've done is learn 10,000 ways to not make a light bulb, right? A little bit later, you'll notice the feet have been changed out for pill shapes. I thought rounded toes would make life easier for them. I have no proof that that's the case. They're supposed to try and move towards each one has its own ball target. And yes, this is actually just yesterday. You'll see I color them when they're touching the ground, which helped me debug some of my information. The gray box in the center is always aligned it's positioned at the center of the dog and always points to the target, which I found was a lot steadier than just using the torso as a frame of reference, because every time the torso jiggles, all your numbers go nuts. And that was working pretty well. Yes, so it does get a little bit better. It does learn over time. But I can't get it to look natural. And I blame this on my implementation of the physics system. Yes, progress pictures. I regularly take snapshots and put them in my progress pictures. So here's an example of the dog setup, one of them. The dog has the torso, and then inside the torso, separate from the torso, which is the physics model, underneath that is the visible model, which is like the brown that you see on the right. And then, of course, all the limbs. That was this morning. Is this animated? Yes, it is. There's a heuristic system where you can type keyboard keys to get it to roll over and stand up. My actual first goal had been try to teach the dog to roll over and get up, because lots of people have taught them to walk, but I'd never see them recover from a fall with grace. Eventually, I kind of gave up on that because I just couldn't do it. It turns out it's really, really hard. So I'm trying to do like everybody else, walk first. I thought rollover would be easy. Like I thought it would be rollover before you can crawl before you walk before you run, and then we get somewhere interesting. We can start setting up an obstacle course. But I'm not there yet. So yes, through careful manipulation of about 12 keys manually, it is possible to get these guys to eventually roll over and get up. You'll see the body has stopped turning green, which means it's up, it fell over. Wider views of what I've been working on. These are range of motion in the shoulder joint. And you can see over here on the right, the stiffness and dampening of the joint. Now, to simulate industrial robots, Unity has something called an articulation body, which does a really good job of being a very stiff physical joint in a simulation. It is not a good simulation of an actual motor attached to a physical block, as you might see. So if Unity, if you're watching this at some point in the future, I would love to have a block, some kind of thing I can just drop in here, a component that lets me put in a torque curve for a motor and say, is this a stepper? Is this a servo? Is this a DC motor? And get a real representation out of that, because that would bring me much closer to real simulation that I could then copy verbatim into the brain of a real robot, which is exactly how I've done. Like the crab robot you saw at the start, I taught it to walk in VR and then translated that into Arduino, and that got it up and moving. The orientation cube I mentioned before, the overall model, each of the sections you see on the right here, this has the physical collision mesh and the visible mesh, whereas back here it's only the articulation body, the physics connection, the hierarchy, and then that repeats all the way down. A lot was learned about stiffening and stiffness and damping, the spring function. If you set it too high, they will jump right off the ground. If you set it too low, they can't stand up at all. So there's a sweet spot, which is difficult. One of the many dogs in our community. I'm really delighted that people have come together and are sharing and comparing and celebrating each other's victories. So that's fantastic. For more about that, you can come to my Discord and you can find all the stuff there in the channel dedicated to robot dogs. I'm not really trying to push that stuff, but I'd be remiss if I didn't mention it. I've tried the same technology training. These are models of a UR5 robot arm, the same kinematic structure, trying to learn to move to their targets. Yes, that's what I have for pictures right now. So here you see the simulation that I've been running this whole talk. And if I can pull it up, this is what I look at most of the day, actually. This is your TensorFlow results. That's the current results from the current training session in orange here. Now, for those of you who haven't done anything with machine learning, it's a black box. You get it. It's a black box, and on one side you dump in a bunch of numbers, and on the other side you get out a bunch of numbers, and you get to assign what those mean. Assign value to each of those. So I put in the angle of each joint, the direction to the blue ball, the height off the ground, the acceleration, the velocity of every part of the creature, and then on the output, I take each of the 12 outputs, and those are instructions for relative motion of each joint. So it'll give me a value from -1 to +1. -1 would be move this direction as fast as you can, +1 the other way as fast as you can. I've also tried with absolute values, where a +1 would be all the way to one side and -1 would be all the way to the other side. Results have been about the same for me. So you feed in a bunch of numbers, you get out a bunch of numbers, and then there's one critical component that you add on top of that, and that is the reward. In theory, you reward it when it's doing the right thing, and you reward it in the right way, just the right way, and it will learn the thing that you want it to do, because it's very, very easy to reward it incorrectly, and it misinterprets what you want, because there's, if you have only one signal to communicate with another creature, it's very easy for it to misinterpret your intentions. Yes. So some things that other things I've learned about that. There's something called dense rewards. If you put your rewards too far apart, it may never discover the source of the other reward. So I give it rewards every time it is moving towards the target, every time it stands a little bit taller, every time it faces a little bit more towards the target, and so on. I thought that I could punish it, give it a negative reward for things like being upside down. If you take the normal of the body it's always either going to be it can't go more than +1, and it can't go less than -1. So I took that directly as a reward. And it turns out that apparently a reward of 0 is already terrible, and -1 is atrocious. It's beyond bad. You don't need to go below 0. I'm reminded of like overbearing parents that are like, what do you mean you got a B-? You should have gotten an A+. A C is a failure. So it feels a bit like that. Yeah. You give them no reward, that they're already miserable. So there you go. I see my old glue has disappointed me.
Yeah. Hey, Dan, I'm going to have to jump in here real quick. We're at time, so just
Really?
4 minutes to wrap up.
Well, okay. Fantastic. So if you have questions, hit me up. And of course, you can find me in all those other places. Go for it.
Okay, thank you very much. Jim, you're up next. Let me get the spotlight switched here.
Which Jim?
Oh, Jim Kinsvater.
Kinsvater, yeah.
Kinsvater, thank you.
So yeah, you were pretty close. Am I showing up on the screen like I'm supposed to? Because I can never tell.
Yeah, I'm just trying to find you and get you spotlighted here.
Yeah, now we've got the grid of participants showing up.
Yep. And Jim, I think, are you just logged in straight as Jim?
I am.
Yep.
Hello. Okay. Well, hey. The host has spotlighted your video for everyone.
There you go. Okay, Jim, you're up.
Well, I feel a little bit humble compared to the first presentation, but I'll do it anyway, because I'm back to my age, still trying to do a Robo-Magellan robot with something less than a supercomputer. And I've been working on that, well, about 10 years now. And about 6 years ago, I presented a robot at one of our meetings that was my version of it, and it was based on a Arduino Mega and a little Pixie camera. And my idea was to use the Pixie camera to find the orange cone, and that was a miserable failure. So I kind of put that on the shelf, and I've been playing around with the Raspberry Pi of late. And so I thought, well, I'd try to rebuild my old Rover robot with a Raspberry Pi, with the idea that, yeah, you can now actually, with the 4, you can actually run TensorFlow and things like that, and perhaps come up with a reasonable solution. I haven't actually done it yet, but I'm learning very slowly. TensorFlow, as Dan was saying, is quite a pile of stuff to learn. It's really sort of interesting. Anyway, I just thought I'd share the mechanical aspects of this, the interesting problems encountered in trying to make a robot from Raspberry Pi, which Raspberry Pi really is not intended to run a robot. It's kind of like using a PC. It's the same sort of thing. It's intended to play games and do computing, and it does that very well, but it has very little relationship to the real world. That's one of the things I really like about the Arduinos, is they actually have A to D converters, and they actually have outputs that you can do and so on. So anyway, I'm gonna try to show you what my robot looks like, but I fouled up the whole system the last time I did this, when I clicked share screen and locked the system up, because I didn't realize that when you do that, you do kind of impinge upon everybody else's stuff. And then when I did that, my screen disappeared. I just had the little grid, didn't know how to unshare. Finally, Lloyd fixed it. Thank you, Lloyd. Anyway, so I'm going to try share screen again, and let's just see if that works. Now, what are you all seeing? Oh, here we go. Okay, share. Can you all see my little robot now? Just
yep, that looks good. Looks good, Jim.
My problem is I can't tell what I'm outputting. When you do a share screen, though your main screen goes away. It's weird, and I'm not really sure how to turn that off. But I'll worry about that later. anyway, that's basically what the robot is. It's articulated 4-wheel drive robot. It's got a little universal joint, and it's based on basically a big backhoe that I used to work with. The idea being that with all this articulation, hopefully you don't have any skidding, and skidding is the bane of any kind of digital type tracking of your procedure. So my robot's got, 4-wheel drive. It's got a 1250 milliampere hour SLA battery in the front and the rear to give it a little mass. And it's got GPS and I guess a SLU, I don't know, it's the B&O 055. It's basically 9-degree of freedom on top up there. And then it's got 5 ultrasonic sensors around the front to try to avoid things. And of course, it's got a pie cam up on the front. Now I'm going to try to shift over to the details of, anyway, it steers by obviously shortening or lengthening this little actuator. And also I changed their RPM, but it's kind of seems incidental because the DC motors don't seem to care whether you change the RPM or not. They just turn whatever works. I only have encoders on the front axle. The idea is being that you're always tracking that center of that front axle. So theoretically, and that's where it is you can come back to home like you should. Anyway, I'm going to try to switch over to the other figure, and that's where I run into problems. Okay. Yeah, that's not working. Oh, I just love my lack of technology. The reason why I was bringing this up was just to kind of demonstrate, wow, it just doesn't want to do what I want it to do. Well, let me try it a different way. Hope you all be a little patient with me. Good grief. I had it all arranged and it all went to pile of whatever. Okay. Okay, is the skid showing up now?
Yep, looks like it.
Okay, the only reason I wanted to show this, and this is really the main point of this whole thing, is to show what you have to jump through to make a Raspberry Pi into a real robot. So the bottom of this stack on the left is the Raspberry Pi 4. Above that, there's a fan because these things do tend to get a little bit warm. Then you stack a motor driver on top of that. Then you stack an A to D converter on top of that. And then you stack some kind of an interface board because the Raspberry Pi only accepts 3.3 volt inputs and most sensors put out 5 volts. So that's basically what I built up to make this thing work. And it's an interesting challenge. I thought it was going to be just real easy. Here I've got a robot that already works, right? So all I have to do is change the CPU and it's going to be a slam dunk. And boy, that was naive at its worst. So anyway, I've got up with this thing and got it all built. I've had some success making it work, but I do not have any wonderful videos of how wonderfully it runs a course because guess what? It hasn't done that yet. So that's kind of the end of my presentation. Just wanted to show you one approach to making a Robo Magellan robot, and we'll see how effective it is. Hopefully down the line a little ways. I've got a local park and I've got lots of orange cones. I'm going to do a little experimenting in there and see if I can't make it work. Now, I don't know how to unshare my screen.
Okay, I can do that from over here now.
Would you please?
Let's see.
Okay.
I've got a button that says stop participant sharing. So, okay, you're clear, and you've got about 10 more minutes left if you want it, Jim.
10 more minutes. Oh my God. I don't know what to say.
Or maybe move to the next speaker, whichever you would like to do.
Does anybody have any questions or comments on this little thing? Any ideas?
Can you sing, dance?
I'm sorry?
For filling time, can you sing or dance? Do you play an instrument? Just kidding. Never mind.
I have to run to the other end of the house, get my guitar, come back, try to sing. And by that time, my 10 minutes would probably be up. And oh, by the way, while I was doing that, my wife would say, "Oh, you're out of your Zoom meeting. Hey, I really need you to run to the store for me."
Oh.
And, you know,
I'm curious if you've looked, because I know that the what is it, the Raspberry Pi Pico is not the same as a like Raspberry Pi necessarily. I mean, it's really kind of two different products almost. But I was noticing the other day, and I hadn't realized this, that you can program the Raspberry Pi Pico or Nano or whatever it is with the Arduino IDE. So you can actually do all your Arduino programming with it. And it has 3 A to Ds, but I think it's still 3.3 volt standard for I/O. Anyway, just a thought. It's a gob ton faster and more powerful than like an Arduino Uno. So maybe it's like a mid-level thing between like using an Arduino and using a or like a Raspberry Pi 4 or something. What was your original robot running on before you started?
My original robot was running on a Robot Mega, or Arduino Mega. Hello.
Arduino Mega.
It worked pretty well, you know, as performance-wise. It did everything I wanted it to do, but it didn't have the capability, basically, of vision. And
right.
And as far as the Raspberry Pi Pico, or whatever they call it, my preference today for my little robots is the ESP32, which is similar to the Pico. I think they're competing in that realm. And one of the things I've been trying to do for, again, about 10 years is come up with a less expensive alternative to the parallax course with the little simple robot, and I'm actually getting close to that now, and I'm using the ESP32 and micro Python, which is just so much simpler for kids to write than C, because you don't have to worry about all those pesky semicolons and stuff like that. And I've had some good response for that. Now, mind you, as you well know, MicroPython or Python itself has its limitations, but there's some pretty neat stuff out there for the ESP32 and MicroPython. So that's kind of where I'm running when I'm doing little line following robots and so on. But it doesn't really have the horsepower to do anything like TensorFlow or any object recognition. They talk about it, but it's so limited that you're kind of stuck with not solving the problem, really.
So that's really your goal, is to put more brains on board the robot, without increasing the cost substantially. Right,
yeah. Now, of course, the last Raspberry Pi 4 that I bought, I paid $180 for, because this chip shortage has kind of nailed us on lots of fronts. So that's interesting. Hopefully that's supposed to get over the end of the year. So not sure if we'll be able to go back and buy a Raspberry Pi for the normal $60 or whatever that they were saying.
Yeah.
Well, have I got a solution for you, but I'll wait my turn.
Right. Jim, this is Donna. I've got a question for you.
Sure.
So as far as the camera that you chose to use with your Raspberry Pi, could you describe a little bit about what product that you chose for that?
It's the very basic Pi Cam. It's nothing. It's not a high-end version of it. There's a bunch of better ones out there, but I'm just starting with simple, and then if that isn't good enough, then I'll step up. It's, you know, these days these little $17 cameras have amazing resolution.
Right.
And so you can get a bigger sensor, and that gives you better resolution and so on. And then, but then you go from $17 up to $60. And I kind of try to pack as much as I can into an economical package. I'm not a high school kid. I'm not fund limited that way, but still, if I ever want to present it to people, I don't want to present them with a bill for $1,000. At my place of work, we're using much more sophisticated computers on our drones, and that's fine. But if you got to spend $1,200 or $1,500 on a robot, that's not something that the masses are going to be able or going to desire to do. So I try to keep with inexpensive ones.
Mm-hmm. Mm-hmm.
Sorry to hear about you don't like the Raspberry Pi, because I'm building my Robothon too, but I'm using a Pi.
No, the Pi is a great, it's a good machine. It really is.
But I did throw money at it because I'm doing it with a robot made in China.
Okay.
That's pretty big and fancy.
It's
got Connect and LiDAR and, huh?
Sorry, go ahead.
Oh, it's got Connect and LiDAR and all that good stuff. I'm learning ROS, and I'm going to be using that to program it.
Cool.
Cool. Yeah, you can run it on the Raspberry Pi now. I mean, to me, that's amazing. You know, it's basically what, $80 computer or something like that, running ROS on that little machine. Wow. One problem I did run into was trying to cram all the different tasks into the time base, and there is this process called, I mean, this is supposed to be a quad core, right? You should be able to run things in parallel in this thing, but the multi-processing is kind of like TensorFlow. It's not real well documented, and it's a challenge. But that's my other task, is to try to find enough computing power to do everything I want to do.
Jim, this is Terry. I have a question. Which version of Raspberry Pi are you using? And by the way, on Amazon, it's dropped down to $118 for a Raspberry Pi 4, fully complemented. It used to be $180, so it's coming down.
Yeah, I've got a 4B, which I paid $180, so I didn't quite pay the max. When I bought mine, it was $180. 2 weeks later, it was $220.
Oh, geez.
I'm glad to hear it's now down. I mean, it was whatever. It was just somebody had a bunch of them in stock, and they were getting whatever they could, right?
Yeah.
And now they're starting to come back into availability, and that's just kind of how it goes.
They had them for $150 a couple of weeks ago, but you could only buy one because everybody else was selling them for close to $200.
Yeah, it's a nutty world. Okay, I'm about dried up here, Lloyd. I think you ought to move on to the next guy.
Okay, Steve, you're up. So Stephen Kaehler, building and programming Makeblock robots. We release the spotlight here on Jim. Let's see. There you go, Steve. You're live.
Right. Okay, let me get over here to get to sharing the right screen. Hopefully, start getting all this stuff going at the same time here. It's like, all right. I'll get that. There we go. All right. Oh, okay. Now I got to get myself back to my script here so I know what in the world I'm going to say. Okay. So let's see. Hello, everyone. My name is Steve Kaehler, and my presentation will show how I'm using a cool robotic kit and programming environment to teach basic robotics to 10 to 13-year-olds. The Makeblock ecosystem provides everything needed to build, program, and operate a variety of cool robot kits, and can even be used beyond what's available from Makeblock. The programming tools can be used for practically any Arduino-based controller, as well as other popular processors. And just a quick, there's my family, my 3 furry babies up there in the corner, and my sons here, my menagerie in my room. Worked for the Boeing company for 35 years as an electrical engineer, retired out of that a couple of years ago. And I did data acquisition system design, construction, operation, and did fuel system testing on pretty much every airplane that Boeing made. They started out with the 777. Here, at this delivery ceremony, I was actually present at this ceremony when they delivered the first one to United Airlines, and I'm kind of disappointed. You know, perhaps you've seen in the news that the 777X is now looking at least next year before first delivery, which was quite disappointing. that program has been going for 12 years that program has been operating. And I'm the Boeing company that I used to work for is not the Boeing company of today. So let's see here. In my retirement, I've kind of been playing around with a lot of stuff, but in particular, I decided to start a business of teaching 10 to 13-year-olds robotics online. And so my first class actually is on Tuesday, and I have a morning class, an afternoon class, and I've got a couple of students for each one. So that'll be a kind of a starting, and we're going to be using the Makeblock. So as you can see from the slide there, it's about $150 kit. It's based on the Mega 2560 and has some built-in stuff. It has a couple of DC motors and then additional ports that allow it to connect to sensors that can be mounted on brackets around it. So ultrasonic sensor, and you can put in DC servos, RC servos, and other such things. Let's see. I found that it's a pretty easy kit for kids to build. The basic package has these 3 configurations.
Well, Steve, you're breaking up a little bit.
Land Raider or Ranger, which is the one that I'm going to have the kids build. Yeah, and that's, of course, it's differential drives, or you can program it. Pardon me? The nervous bird down here. Okay, maybe if I slow down a bit here. So there's 3 configurations that the kit can be put together in, and I've chosen one. Discovered that when I did this class in person, that having these different kits, because the programming is entirely different between them, it's very difficult to help all of the kids make progress. So we're going to select just a single kit. The processor is this, they call it a Miariga, and it's kind of a strange name for this thing, but as you can see, it's got some ports. These are RJ25 type connectors on this one side, which are for drive motors and other things. And then on the other side, it's got these 5 ports for sensors. And then this cool ring of 12 RGB LEDs that you can control individually. And I'm going to show you a little bit of what I can do with that. A couple of light sensors, so you can make this thing into a follow a flashlight type deal. There's a sound sensor. You make a clap and you can make the robot respond to that. And then a buzzer that you can play tones on, as well as just make noise. So it goes together kind of like an erector set. It's got nuts and bolts, and it's pretty simple construction. It takes a little bit of time, but it's pretty easy and comes with all the tools you need to assemble it. And then the programming is done in a building block style, somewhat like Blockly Prop that Parallax uses. But this is based on MIT's Scratch 2.0. And so very, very simple building block environment. Kids can, in just a moment, literally can create programs. So I'm going to show you a little bit what that looks like. And let's see here. I didn't go too far, did I? You can remote control the thing with a smartphone or a tablet, and one of the cool things is this simulation mode where you can the program actually runs on the computer that's connected to the robot rather than on the built-in processor, so that you can simulate your program, and then once you're happy with it, then you can upload it. Yeah, that never know about the upload here on my internet connection. That's probably what's kind of messing up you guys. It will work with any kind of computer, including a Chromebook. Does not require a subscription to do the Chromebook stuff like the Arduino.cc. So it's a completely self-contained and basically free environment. And then you can use programs off of the Scratch, the MIT Scratch website, and just rename them from .sb3 to .mblock, and then they'll load into the mblock environment, and then you can tweak them to function with this robot. And let's see, websites. The websites for the for these two different guys, I don't have the actual website on there, but the Makeblock website is just ide.mblock.cc. And the website for Scratch is scratch.mit.edu. And you can visit these places, and you can, they've got example programs. The MIT website is awesome because there's thousands and thousands of programs of all different kinds of functions that people have put there. And so you can go there, you can grab something, borrow it, bring it into the other, thank you. Yeah, and then scratch.mit.edu, if you don't mind putting that one up as well. And so let's see here. How am my phone? Okay, I still got about 6. So let me just switch. I'm going to switch my view here to camera. Okay, so this is the, let me see, I'm gonna pull this back a little bit so you can hopefully see that a little bit better. So this is what the robot looks like. It's actually pretty cool. I did have to do one mod to the design of this thing there. It turns out these treads, they're continuous treads, so there's no joint in them. And so when we first put these robots together, the motors couldn't turn the wheels. And of course, treads require a lot of power anyway, but it turns out that the treads were actually too tight. And so we had to move the, this lower wheel here, had to basically move it up a position in order to give just a little bit of slack in the tread. And then once it did that, then the motors were able to move them. However, they still eat batteries. So, this kind of a configuration is just naturally going to be battery hungry. You can see that it's currently hooked up. It's hooked up to just a standard Chromebook, and the environment. Then let's see. I'm going to go switch here to yet another. If I can get back to my background here. This is what the environment itself looks like, and I would expand that, but I don't think it actually gets any bigger for you. Let me try this here. I think it's, yeah. So it makes the background bigger, but it doesn't make the blocks bigger. So I don't know how much of that you can read, but they've got these different category instructions, and you just, you grab instructions, you drag them from the toolbox over here to the work area, and then just link them up. You've got loops, you've got test statements, you've got operator blocks. The sensing can be, in this case here, you see that you've got light sensor, temperature sensors. Oh yeah, I forgot to mention it's an onboard temperature sensor. You just click the little checkbox over here, and what that will do is that will cause the value of that sensor to appear over here in this little window, and it's probably way too small for you to read. Let me see if I made that. Let me make that a little bit bigger. Okay, I don't know if you can, maybe you can kind of read that, but anyway, if there's a sensor, if the sensor is actually running. And do this here. So I go down here to down at the bottom of the screen. I'm in live mode. I do connect, and let's see here. Darn it. Well, let me see if I can. Let me try that. Go into that screen again here and see if it'll see it this time. It should appear over there. There we go. Okay, so now it's showing it's showing the device connect, and the robot beeps there indicating that it is connected, and that disappears nicely up over here in the screen. And I don't know if you can read it or not, but it's showing about 704. If I take my hand and I put it over the top of the light sensors, now it's going down, it's down to about 23 at the minimum. And so you can read out the sensor values and figure out how they behave based upon what you want to do. And then, so it gives you the ability to monitor these sensors. You can, there's an alternate way to get things over here. And that is what I've done with these other ones. There's this X-axis sensor up here, and let's see if it's responding. Oh, I know why. I have to run the program. Sorry. Okay. And there we go. So in this case here, this block on top is there's a variety of blocks that you put in there, but you can cause the program to auto start when you're disconnected. The program is uploaded, so there's a different block for that. You can choose one where you click on the green flag and it makes it go, or in this case when Inky is pressed. And so and then I've got the programming is currently set to change. Let's see here. Let me move this out of the way so you can see better. So you can see the LED on top of there. The program changes the LED from 1 to 12 based upon the value of the sensor, the angle sensor. And so it's got a 3-axis sensor in there. And so I'm just using the ring of LEDs as a way of providing an onboard feedback. And yeah, it's running really slowly. Probably doing this during a Zoom meeting is sort of less than optimal. So I'm almost gonna guarantee that it doesn't like that combination. So let me see if I can get back up here to Block. Get this guy back up. Okay, so it looks like according to my timer, that was 15. I can try to answer questions. Thank you for posting those links for me. Oops, let's quiet that thing down.
Steve, this is
anybody.
I have a question.
Go ahead.
The light sensors in the first, I think one of the early pictures that you showed, you were kind of pointing to light sensors and they seem to be pointing upward. But maybe I was misunderstanding that. Are they actually facing forward? Because you were talking about light following, and I would think that they need to be facing forward to work for that.
Yeah.
Or do they move?
Yeah. Okay. Let me explain that a little bit. So see this guy right here. This is one of them, and then this is the other one. And so they're on top. Less than optimal for something like, let's say you want to be able to shine a flashlight on the floor in front of the robot and have it track that.
Right.
This would not work for that. See, so in that case, though, the alternative is to plug in a different kind of a sensor, either for example, this little guy. This is the sensor that will detect. You put this thing down and it looks for a black line on the floor, and it uses an RJ25 type connection, and then that plugs in one of these ports on this side, and then in the software you just tell it which port you're plugged into. This could potentially be used if it was, let's say, angled slightly forward, might be able to be used that way. So it's a pretty basic kit. Kind of optimized for just getting started. Doesn't the sensors, the light sensors on top, the way you could probably make that follow a robot would be by putting, let's say, a piece of cardboard or something in them that blocks light shining at the robot from the one sensor versus the other, so that it gets a different intensity based upon the angle of the light hitting the robot from above. So that's kind of how I would envision doing that particular function.
So you'd sense light.
Any other questions?
Oh, sorry. So you would sense light on the left side or the right side of the robot, and then you could instruct it to turn based on whether it was receiving light on one side, kind of thing.
Yeah. Probably turn to try to sort of equalize the intensity so that so that it's seeing about the same intensity on both sides, which means that it's pointed at you or pointed at the light source. And it would probably have to be in a dark room for that to actually work very well, because I'm sure, other lights in the room would probably mess that up. So,
yeah. Hey, folks,
so
I'm going to break in for just a second.
Any other questions?
Oh, let me break in for just a sec because we're at time. But what I want to do next is go ahead and we'll do a 10-minute break, and you folks can keep chatting and answering questions. Steve, can I just steal the screen to put up a timer? And then everybody can just keep chatting, and we'll come back in 10 minutes. And Chaz, you'll be up next.
Okay, go ahead and take over, Lloyd.
Okay, thanks.
Thank you very much.
Yeah, you folks can keep chatting. I'm just going to put up a timer so we all know when to come back.
Did you have in mind that there would be a differential drive in which each side of the drive would be operated by a different one of those light sensors?
I guess that would be one way to do it. I mean, it would just be a matter. I mean, you can do whatever you want with the programming. The motors themselves have encoders built into them, which you can use. There's options for reading back the encoder data that will tell the program exactly what the motors are doing. Obviously, dealing with slippage and things of that sort makes encoders, wheel encoders, kind of iffy. So my thought would be more using the light sensors themselves as the feedback mechanism. So, a darkened room, you point a flashlight at it, but put a divider such that the two light sensors would see that light differently depending upon the orientation of the robot relative to the light source. And then just write a simple program that just causes the robot to try to line itself up, get those two close to each other, or get the indication that it's actually pointed at the light source.
Well, if I wanted the machine to, in fact, simply follow the light, I wouldn't use the wheel encoders at all because of the image of slippage that you mentioned.
Right. I would not either. The programming, I would simply nudge the wheels either the left or the right based upon some criteria. Look at the since I can put the light sensors up on the screen, I could then stand off at a distance and I could shine the light on them, and I could see how the light sensor values vary depending on what's happening, and then I would code that into the programming to cause the robot to turn appropriately, whatever that looks like. That make sense?
That makes sense.
Yeah. Any other questions about this? And otherwise, I'm happy to yield the floor to anybody else.
I like the platform. I actually, after I saw you using it, I actually bought one of those. But I kind of gotten overloaded with overtime at work, and so I haven't really played with it very much yet. But I like it's really set up quite nicely so that you can get to working with the robot quite quickly, and I think that's pretty cool.
That seems to be their goal. Yeah, the between that and there is they do on their website, they explain how to add the libraries that are needed to talk this guy to the Arduino.cc online repository, so that you can then, you know, write your programming in just standard Arduino C, which you know, people prefer. My experience with kids, the kids that I've been working with, is that they just don't have the patience to learn the syntax and vocabulary of text-based programming. And so, you know, this building block, you know, drag and drop thing is so simple and so easy. You know, you can literally, within less than a minute, you can have a completely functional program running on your robot. And it's really, it's kind of fun to watch. You know, kids they just off they go. You know, it's actually pretty cool. And it gets them excited about what they can do with their robots.
So tell us a little bit about your school, Steve. I mean, you say you've got what, 6 students now or something like that?
So I've got 4. I'm hoping to get more. I up to 10 is my kind of my goal. 10 per class. So it's all online, all virtual. And this starting Tuesday will be 6 weekly sessions, an hour per session, probably a little more, because I know it's gonna go longer than an hour, but I'm calling it Mr. Steve's Robotics Club. So that's my clever, catchy name that I came up with. And I'm doing it as a business, just offering these classes to parents that are looking for something for their kind of 10 to 13-year-olds to keep them busy. And I'm pretty excited about it. I've been working my buns off trying to pull all the bits and pieces together. Any of you have ever taught a class on any subject, you know how much work it can be to pull everything together. So
how do you market it?
Pardon me again?
How do you market it?
Broke up.
Curious about how you find your students.
Primarily Facebook, and then Facebook to find potential people interested. I posted something on the SRS mail list here a couple of weeks back, and then I usually just direct message people that express interest, and then I have some private groups, and it's basically 2 layers. There's a kind of a general interest group that people can join into, and then the next beyond that is the actual class group, which will only have currently the 4 student members in it. And then of course, I'll be recording the sessions and then make those available to the students, and indefinitely, as far as I know. So, and they can rewatch their sessions. They can watch the ones from the other class. So I'm doing a morning class and an afternoon class to provide a lot of flexibility on different time zones and particular situations, parental situations. So one is geared toward kids. The afternoon session is kids who are in regular school. The morning session is for kids that are probably being homeschooled. So there's a lot of both out there. So looking to try to reach out to as many people as I can. So
you've got a question in chat.
Pardon me?
There's a question for you in chat about your class.
Okay, let me get back there. Let's see here. Doggone it.
I can read it for you if you'd like.
Okay, I'm just getting back. You offering this class online? Yes. Yeah. So somebody in Dallas? Absolutely. Yeah, Carl. You can connect with me at well, actually, let me give you the actual email. Is Mr. Mr.Steves, STEVES, Robotics Club at Gmail. So yes. So go ahead and reach out to me at that email, and I would be they will, at this point, because of my class is starting and the students need these kits in order to participate, I'll put them on a waiting list, but I'll probably be starting another one of these up in maybe mid to late October, and that'll run into November. And I'm planning to, and not yet, I do have a Facebook page, and I'll send an invitation. So via that email, I'll send a link to the Facebook page where you can find out information and how this thing works. But yeah, I'm love to have a bigger classes next go around, and I'll probably be a little smoother at it by then because I will have actually been through the 6 sessions, and so I'll be looking forward to maybe this thing getting easier as time goes on. All right, thank you. Yeah, thanks, Carl. So I know there's lots of interest out there, and I'd love to tap into anybody that knows people or kids that are interested in getting into this. So,
Steve,
yes.
Do you find that your students don't like using books to look up stuff?
Since I haven't started yet, I'm not sure about these kids. Some of these kids love reading, and so maybe, but I'm looking to get to know them a little bit better. So I don't know yet. That's a good question, though. Yeah, because a lot of kids today, they kind of expect everything to sort of be served up to them. So
yeah, I've been doing some tutoring in Python, and I find that they want to know the code right off the top of their head, and they don't want to have to go look in the book for an example.
Well, that remains to be seen. Okay, it looks
that's
like
what I want too. I've only been programming for like 40 years, and that's what I want too.
Okay, folks, I'm going to jump back in here for a minute. That was our 10-minute break. Back up here. Chaz, looks like you're up next with the PopBot and SRS PopCan challenge. Go for it.
Great. Good afternoon, everybody. Let me move some stuff around here.
Woot woot.
What screen am I sharing?
PopCan challenge, PopBot's future and past.
So you, okay.
Spotlighted here in just a second.
It looks like Steve's video is still pinned.
Yeah, I'm fixing that. There we go. Everybody see that now?
Yeah, it looks good.
Okay.
All right. Okay. Yeah, good afternoon, everybody. Let me grab a link here. And where's my chat window? All right. I have a couple links. I'll drop them as I go. This is my first time using Google Slides. Usually I use PowerPoint. So we'll see how this goes. Death by PowerPoint today. Today I'm going to talk about presenting my series of robots called PopBots, and they compete in the Seattle Robotics Society's PopCan Challenge competitions. I'll talk about a little bit about the PopCan Challenge itself. It started in 2016. The competitions have passed, and then the evolution of my robots through the competition. Let's see, go this way, go down. How do you go forward? There we go. A little bit about me. In a nutshell, this just says I didn't come from a background of robots, so anybody could do this. I started out working in Kent at a little electronics store called Supertronics when I was in high school. Somebody gave me a basic stamp, so I learned basic on that. Somebody else gave me an ELF2, so I learned machine code on that thing because you had to type in that's hexadecimal. The hexadecimal functions and hit load and continue on. So I got to learn about electronics early on, and I liked electronics, so I built some interface boards for my Amiga 500. There used to be an Amiga store behind Supertronics. In 97, I joined the U.S. Air Force. My electronics tinkering were mainly ham radio electronics, you know, RF stuff. In 2001, I got out and I was a broadcast engineer, radio station sort of stuff, not television, just radios. And then I had another job as a service manager for a company, and I migrated to 8-bit microcontrollers using the PIC series of 18F and 16F micros, and I learned all assembler. I didn't use any C or anything, and I graduated down from basic. I'm not sure, but you could do a lot more with assembly than you could with basic, I felt. In 2005, I took the role I have now in work, and I program PLCs and application-specific controllers. So that's what I do day to day. Now I more have a training function than actually doing it. And then I started getting into robots. I made a Sumo Roomba robot, which was a lot of fun. That was my first robot, probably. This little robot that used to just follow my wife around to annoy her. That was a fun one. And then again, RF projects, mostly 8-bit microcontrollers for like some sort of communication motion. And then in 2016, I started out with my series of PopBots. And as I said, PopBot competes, or the PopBots have competed in the Seattle Robotics Society's PopCan Challenge. Mark Kenworthy designed, as far as I know, he designed the PopCan Challenge. He reached out to me in late 2015 just to talk about it if I was interested in it. And I was honored actually to be able to help out with some minor portions and building it. It was first hosted in 2016 at the Robothon. The left-hand photo, if you're looking at the same way I am, is the overview from the mezzanine down into Robothon. And so over the first 2 years, we were up in the mezzanine. And then the middle photo is actually the challenge. I think that was the 2018 year right there. And there's the arena in the Armory in Seattle. The challenge is an autonomous navigation challenge, I guess. It's a little bit about obstacle avoidance, but mainly, I mean, it runs an indoor simulated environment. In a nutshell, the robot navigates from a starting point, which is a simulated living room, navigates through the home to a kitchen, opens up a refrigerator, grabs a pop can from the refrigerator, and then goes back into the living room, places it on the table, and then goes to a finishing point. I threw the link. Yeah, thanks. Thank you, Terry. I actually threw the link up a little bit before, but thank you for throwing them in there. I appreciate that. Get back in here. So my PopBot versions over the years, I started out with 01. There's no PopBot 1 because PopBot has not been successful, so it does not get rewarded with a 1.0. But 0 and then 16, and then through in 2019 was 04. And I'll talk about these later. We didn't have Robothon in 2020 or 2021, but I did build different robots during those times because it's for me, it's a lot more about making the robots and discovering how they work better because I don't have a background in it. So this is the two competitors in 2016. I don't remember Mark Kenworthy's pop. It's like Pop Getter, but that might be John's, but he can tell you because John's like 2 people after me, I think. So, and I won't run too many details because I have no idea what his presentation is. But there was 2 robots. My robot's the one on the right with the big elevator looking thing. And I'll talk a little bit about each robot after these are just the people that placed through the years. 2017. We got some more friends. I think Mark's robot didn't win this year because he blew up a motor driver. So my robot changed a little bit, sitting there in the middle. And then there's 2018. And then 2019, I didn't place. I made a really nasty mather that, of course, didn't present itself until the actual competition itself. That caused me just to sit there and do circles. That was a real bummer, but there's our winners there. And so the PopBots have passed. So I started out with 01, and this is how I developed my PopBots. Well, actually, this is the reasons I changed my PopBots from year to year. The first year of the PopCan challenge, I just fell in love with the idea of having this like elevator sort of masked thing. So, and really I just call them PopBots because that's the one thing that I've kept the same throughout the robots, even though everything else about them has changed. So the first one has an elevator and it grabbed at the door with this like lower lift. If you can barely see down below here, it's got this little hook where the whole elevator system actually tips back and will grab the bottom of the door to pull it open. It's powered by a single PIC 8-bit microcontroller. It was completely written in assembly language, had limited performance because of that. And the real issue with this was I was sitting there watching Mark, just like he had an Arduino Leonardo or something. It wasn't a Mega, it was close, so, or Duo, that's what it was. And he's sitting over there with the Arduino IDE, which I've never used in my life at this time. And he's just like banging out code, just fixing things. I'm sitting there writing assembly, which it takes a long time to make changes. I mean, you're copying and pasting as much as possible, but the tool chain just caused like a lot of delays in being able to like tweak it. And I was very, very jealous. Carol asked, where are the PopCan challenges being held now? Technically still the Robothon, right? They'll just be next year at the Armory. We do have one, which I'll share at the last slide. So this version had a 2-wheel drive NEMA 23s for stepper motor. So stepper driven. The rear motors were Omni wheels, so they didn't jump or anything when you're turning. The wheels were actually rollerblade wheels, just with like hubs on them. And I ran this giant 8 amps steel lead acid battery. It's this big blob that looks like it came from 2001 Space Odyssey right up here. And that was a ballast and a half right there. It was built on a 12-inch square 1/4-inch aluminum plate. I don't know why, just what I used. The benefits were it had a lot of pulling and lifting power. Like it was great. It was very slow and like it was right up against that 25-pound. Well, it used to be 25-pound limit. It's a 35-pound limit. But the day of issues, and I tell you what, if you're building a robot, test your robot full out beforehand, which I'm really bad about. But my stepper driver motors overheated, and I had to like program in pauses, so it would go like 4 feet pause for, I think it was 16, 17 seconds I counted, and then it would go again. So it had like all these weird start and stop plays, but that was the only way I could get it to run that day. Yeah, thanks. O2, we had a better year in O2. Same thing, elevator with a door lifty mechanism, was slightly different. Again, the elevator tilted to grab the door from underneath. It had a little like plastic bolt that I felt like grabbed better. The first year I actually picked up the entire refrigerator. I don't know if anybody remembers that. Like I got underneath it and just like lifted the entire refrigerator because it's not very heavy. There was just too much plate underneath the refrigerator. I got smart and I actually programmed this one by an Arduino Mega because I was jealous of the reconfiguration. It did have 2 PIC microcontrollers for individual stepper motor controllers. Like the PICs were the stepper drivers. Well, they were controllers. They had separate drivers, but those were I2C slaves. If anybody cares. And I learned C. I learned C just for this competition. I was like, fine, I'll learn it. I delayed too long. I'll learn C. Upgraded the motor driver so it would actually make it. Still, it was 2-wheel drive NEMA 23 steppers. It was same drive system. Rollerblade wheels again, same battery. I didn't change it out. Same plate. Again, up against the 25-pound limit, and did a good job. Open and close the door. That was a good year. Third year, I made some changes because of the weight. I just ran out of weight, so same elevator system, slightly different. Well, actually, each elevator system was written different. I got inspired by 3D printers and changed the gantry out to something a little bit more 3D printer driven belts this year instead of lead screws. I think the later ones, I don't remember which one's the lead screws right now, but again, powered by Arduino Megas. I switched to Nanos for the stepper motor controllers, still I2C. Upgraded the motor drivers again to try to get it to be faster because again, it was a very slow robot. Still rollerblade wheels. The rollerblade wheels this year, this was our first year down below, and actually ran into a problem where, and again, it only happens when you're actually in the competition, not during practice at all. twice I got hung up on like, it's a poured concrete floor, and it's got like, they're not exactly like level. So the very low profiles you see down here, the whole frame sits like a quarter inch off the floor, and twice it got hung up on the floor. So I bottomed out, and you'll see I had to make some changes. Because I was out of weight, I switched to these extremely expensive nickel metal hydride AA packs. That worked out pretty good. And I started, and I had like from other projects started using extruded aluminum. So I like it, I love it, I still use it. This one, again, still great pulling and lifting power. It was slow to the point where, I mean, it was probably faster than the ones before, but since we were down on the main floor, we had a lot more visitors. And I remember some kid asking me why my robot was so slow. And I'm like, why are you so slow, kid? I mean, I didn't really say that, but I said it on the inside. And so I got the hint. It was too slow. My steppers weren't doing the trick, and not least with the setups I had. Yeah, so I decided to switch everything up. PopBot 04 was DC motors with encoders. Had a wider elevator, I don't know why. I decided to go with that, and I went with a lead screw design. I still kind of do. Failed to pull the door open. The grabber, again, was, it actually had a separate grabber system. I'd use this weird little bendy angle thing that I did not properly design. Still powered by Arduinos, just in one Arduino Mega. I found that to be a real issue because, you know, you're switching between tasks, you know, and, you know, you might actually not be able to drive the robot at the time. I learned some we'll talk about fixing that in the next versions. I went to a RoboClaw motor controller, two-wheel drive, Pololu, DC motors. I went to scooter wheels, same batteries. This was much faster, but I found that I didn't have at this point enough traction to open the door. Again, not testing enough, like working up to like the night before the event. And just on that, I'm testing it on linoleum in my home, and on the flooring, I couldn't get enough traction to open the door. It was much faster, which was awesome. And it was 35-pound roll friendly. We switched 35 pounds this year. But it was a big rewrite, and I had some serious code issues just from like not enough testing, which was a bummer. So that was 2019. In 2020, we didn't have anything, but I went to 4-wheel drive with those, I can never say the word right, mecanium or mechanim, whatever, those wheels that you can drive in opposite directions to turn left and right. And this is my in the upper right-hand corner, you can see that robot. It's similar. The big problem with this robot was it worked okay, but it was really noisy. Those wheels are so noisy, like really annoying noisy. So I went away with that, and I finally decided that the door is tight enough that you almost drag the refrigerator with it when you have to open it because it's so light. That was a question from Carol. That I was designing these things based on, you know, my needs, right? I liked using certain things. You have a certain weight class, they have to keep it in and under. I really liked using an elevator just because I thought it was fun. I switched to O drives for a while, these open brushless motor drivers, and I struggled with that. So I switched back to 4-wheel drive vehicles. So in 2022, I actually decided to actually design the robot before I built it, instead of just building and designing as it go. And so everything was built in CAD. That's the lower document. That's the current robot right now. It's actually technically behind me right there. And I'd used 2D CAD fair amount, but I never really 3D CAD designed before. So this is just like a couple things are missing, but this is the 2022 PopBot. And this is the PopBot of now. So a couple key features about it. It does have an aluminum extruded frame, but almost everything is 3D printed down to the 4-wheel drive steering system. All the panels are 3D printed just to try to drop all the weight that I could. So everything's 3D printed and pre-designed and tweaked as I go. So it has an elevator system now, and I don't actually show it to you because I don't know, I didn't take pictures, so sorry. But it's a duplex mast, so it's kind of like a forklift, right? So it nests in on itself. It's all 3D printed with the exception of the drive itself. It's 4-wheel steering with 4-wheel drive by NEMA with the same NEMA 23 steppers. So there's 3D printed here on the right-hand side. You can see the 4-wheel drive system is driven with servos. The BaneBot wheels, I run LiPo batteries now. They're very light, and surprisingly, the 6S batteries last, well, I used it for like half an hour in our last test session without a problem. They were about dead. I mean, not dead, but time to stop using. Still 20mm extrusion. And then the finger grabber, I'm not trying to grab the door from underneath anymore. It's just not working out. So now I have this like linear actuator system with servo that actually grabs it as a finger from the side of the door. And testing it seems to work out. Although I've noticed I don't actually need this whole linear actuator, which I won as one of my PopBot challenge like fodder, which I really just need a finger and need a reverse to grab the door open. Okay, I'm almost done. I promise, 2 minutes. Right now, the electronics of it's all Arduinos. I have 4 of them. They all talk by CAN. Then they talk through a 232 port to a Raspberry Pi. So it's Arduinos with CAN controllers, and they have their individual functions. And then just a shout out to, I believe his name's David Anderson. I'm going to copy some links here. But it's the Dallas Personal Robotics Group. Because I am drinking his Kool-Aid. He has this great 2-hour video on subsumption programming with his robots, and it's excellent. It's dropping in the chat. Watch that video. It's 2 hours well spent. And I've decided to use Node-RED for a bridge to ROS2 because ROS2 doesn't have 8-bit like support anymore. They dropped the ROS serial. So I'm using a Node-RED for my arbitrator. So that's all. So sorry, not enough time for questions, but sometime if you want to talk about it in another meeting, I will.
Okay, folks, we're moving right along here. So let's see, hang on. Next up is Dodgen, function prototype of a telepresence robot. So Doug, go for it. Doug, are you here?
Sorry, it took me a minute to get unmuted in the way of the camera. I should be there now.
Yep, you're here and you're set.
Okay. So I'm Doug Dodgen. I've been a programmer since Moby Dick was a minnow. Started with a TRS-80. And I'm going to be talking about Roby over here, who I've turned into a telepresence robot. And he's functional, he's a prototype, he's not pretty, and he's not good at it. But I will be demonstrating it. Let me see if I can share my screen here. See what that gets me.
Yep, that's working.
Yep. Go. You get this out of the way. You don't need to see yourselves. So we basically started with our telepresence robot. I'm bringing up this little diagram here. We started off with our telepresence robot late in the pandemic because we had a bunch of members join our Tuesday night. We call it Zoom, but it's really Google Meets. And a lot of them were not from around here. So we got worried when we got back to meetings like this, how are we going to include them? So our president, Carl Ott, came up with this plan for a club to create a telepresence robot. Most of the people joined up, and I can't remember everybody's name, and I didn't put it on this one, sorry. But Carl, of course, was the project manager. John Kuhlenschmidt, who I probably mispronounced, came up with a good example of a telepresence robot on the Instructables website, which I volunteered to implement. And that's how I kind of got stuck, or stuck's not the right word, but in this telepresence space. And then we had a remote user out in Connecticut called Chris Netter, and he came up with a good way to remotely control the robot with Amazon Web Services. It wasn't free, but it was really cheap. And that was a good one. Donna Smith from Seattle had a lot of input on different ways that she came to do remotely. But since I was using VNC at work and it was free, I decided I'd go ahead and use it. You can see on this little diagram here that a telepresence robot is basically any old object avoidance robot, but then you have to throw on remote connectivity. And you do that with the VNC, you remote to the Raspberry Pi's desktop. And by the way, the computer has both a Raspberry Pi and an Arduino in it. The Raspberry Pi desktop has to run a GUI, which then gives you the ability to drive the robot. And then you have to put a personal telepresence device connected to it. And that is being controlled in this instance by Skype. Skype isn't the only way, but it has the advantage that it can be used by non-Apple things. Apple has FaceTime, which does a great job between Apple things, but unfortunately, Android phones don't play nice with that, I don't think. And my Windows tablet doesn't play nice with that. So Skype is universal. That's why I use Skype. There's other ways to do it. We originally intended to do Google Meets there or Zoom or any of those video conferencing things, but I detected that there was a problem with audio feedback when the remote person driving around showing the Google Meet screen and he starts talking, he takes control of that screen there, but there's feedback between the robot saying what he's saying and the Google Meets is saying what he's saying. But with Skype, we don't have that trouble as long as some people turn off their audio, which I had to do in order to keep from getting a terrible feedback here. So getting back to the design of the robot, I had a Ryobi battery, which is 18 volts. It's a power tool battery. It's got lots of power. It lasts a long time. Good for meetings and all that. And I used this diagram here to explain how I took the 18 volts from the Ryobi battery and I split it down to 9 volts for the Arduino and the motor controller and 5 volts for the Raspberry Pi and the sensors. FYI, I don't currently have the sensors hooked up. They're in place, and I unhooked them when I was changing between a Roma around the house robot and a Telepresence, and never put them back in just for this prototype. But I still kept it in the design because when I do the production version of the Telepresence robot, it will have those sensors in it. And just to leap ahead, when I finish the project, I'll put the full code, parts list, and everything up on the website so everybody else can duplicate it. And let's see, sneaking along here. There's a picture right there of the power distribution board looking down into the body of Roby. I pulled his head off and that's stuck down there. It's kind of a multi-layer thing, and I didn't have pictures of the other layers. But underneath that board there's a shelf that has the Raspberry Pi, and then underneath that is the Arduino, which then has the motor stuff underneath it. I basically pulled everything out of the Roby except for the motors and put new stuff in to make it work. Roby was a 1980 style Tandy robot. This is right screen. Roby was a 1980 style Tandy robot, and it could be driven with remote control, but it didn't do anything. It wasn't autonomous. It could play back what you gave it, but it couldn't really do anything. But what you see on the screen here, and I'll turn around to the real one in just a minute, but this left side is the driving screen. You've got the controls for driving the robot around. This is the camera that the robot has on front. It's just a webcam. And this is the Skype view. And since they're kind of pointing in the same direction, they're showing the same view. They don't have to, but right now they do because I don't have a swivel on the camera that's the driving one. I will be making a swivel on that so he can look around, doesn't have to always look forward. But for the prototype, that was plenty. I needed to get this thing working in time to show it off today. So we'll be kind of showing that live in a minute. I made a picture just in case my live didn't work, and it almost didn't. Shout out to Carl Ott for finding me a cable. I brought all this stuff here today, but I didn't bring the little cable that connects the Raspberry Pi 4 to the HDMI. So I couldn't get the thing on the internet till the last minute. So what I've got on the screen now is that my discussion about what I was going to do in the future, and you can see some links there. I linked to Harold Pusher. He has a really good Twitch channel, and he gave me the Robbie. So I was really pleased about that. So I could get him to this point. And I think he does Wednesdays and Fridays. I was going to ask him, but he wasn't here today. And you can see where I'm doing my refurbished project on Robbie that eventually got to this point. And I'll take him back apart and making my roam around the house robot again, and that'll be up there. I put in a link here to how to get VNC to work on a Raspberry Pi. It's there already, but get the viewer on your computer attached to it was a bit of a trick. It's free. It's a free download, and for any legal email address, you can control 5 robots for free. So that's why I picked it. And like I said, eventually the entire project will be posted right here on the Robot blog site, and also probably on the DPRG site. So I'm going to stop sharing and ask real quick if anybody had any questions. I went through that pretty darn fast.
Did I understand correctly that it has 2 cameras, one for driving and one for the actual view? Is that right?
Yes. I'm going to point you over to my live screen here. This is my live driving screen here. It's interesting, it's backwards from what I see. This is the live view from the Skype view on the Raspberry Pi, showing the people behind me here. And because that's interesting, I would have thought I would be up there. Let me close that little thumbnail. Yeah, there's me. That's what's showing on the robot itself. So I get to run around, and like I'm not in this room. If I was in Connecticut, like Chris is, his face would be up there, and this is what he would be seeing. This is the driving screen right here. So you can drive forward, backwards, left, right, stop. And this is the driving camera, which is actually on the robot. This is the Skype camera. See how they're similar, but not quite the same? The driving camera is down lower, so it can see obstructions. The Skype camera is up high. And let's see if I can get a better view of that. There's the driving camera in the front. And then you like for the telepresence camera to be closer to person height, or at least a 6-year-old height or something. So there I am on that screen. And see, I'll just put this on the chair for a minute. Have some fun with this guy. That's pretty darn close. See if I can make him move. Right now, he's not really great at moving. He walks kind of like a drunk, because them cheap little motors he's got, I put some extra weight on this guy, and he is not really good at this. You see, you can tell he's bearing off to the left. I have to keep adjusting. See how in the driving camera and everything.
You need to talk into the mic a little bit more. We cannot actually hear you. The mic is noise canceling.
Sorry, I put the mic over there on the chair so that y'all could watch him. Maybe this will work.
That's better.
So there he is going toward John, which we talked about a minute ago. I butchered his name. He didn't say anything. And we'll make him. So basically, I'm not going to make you watch me drive him all over the place, but for my current implementation, the turn is like a 30-degree turn, and then forward and backwards goes until you tell it to stop. And right now, the camera controls are not active for moving the camera around. The driving camera is going to eventually be mounted on his head on one of those things that turns and points and everything, driven by I2C, which I've heard about, but I don't know how to do yet. I'll learn how to do that on the primary one. And basically, I think that's all I had. Any more questions around?
Have you face planted it yet?
1 to 2 second lag. Yeah, I didn't mention that when I was doing it. When I click on these buttons, it takes 1 to 2 seconds for it to go across the internet, come back to the robot. So it's a little bit of skill driving. Good thing for object avoidance once that's implemented.
Have you face planted that screen yet?
Face planted it?
I mean, has the robot tipped over forwards and smashed the screen into the...
Get back over here. I haven't done that because in this particular implementation, see that Ryobi battery on the back? It far outweighs that screen, tilted back just a little bit to help prevent that. So that's one of the reasons.
Some good weight on the back.
Yeah, that's one of the reasons they drive so badly is they added a lot of extra weight there that those little old 6-volt motors just weren't ready for.
I love that the way that the Ryobi battery is attached to the back. So if in the future, if you need to, you can quick swap the battery to keep him going.
Definitely. I cut out a wooden block to hold a piece that I got from Amazon that the battery plugs into, and it works real great. It just added a couple of pounds.
About 4 years ago at Parallax, we started a telepresence thing, and they were fast little robots. I still got them around here somewhere. But the problem we had, we were using Twitch for our site, and we get a lot of these young guys on the site that just would take over the robot and try to run them into walls and break them and that. So, and of course we had the doors closed to other parts of the site, and they'd bang up against the door wanting us to open it so they could wander through the whole place. And it just got to be a nightmare.
Yeah, that sounds like fun and not fun. This particular implementation, since it runs on VNC, you have to have the VNC password. And operationally, what will happen during a meeting is we will have the Skype up and running. One of our members will call in with Skype. We don't have to answer the ton of people that try to spam you on Skype. We know which numbers we're looking for. When the person comes in, at that point, we'll give him the VNC password, which we'll have to change every meeting so that old people won't know it. And we give him that during Skype, not during the meeting. So only he gets it. And then only he can get in, I say he, but them, can get in and control the robot over VNC.
Ours was open pretty much to the general public because it was also being used by Parallax.
This would be a password
advertise.
Yeah. This is a password controlled driving screen. Skype is only one person at a time into Skype. So I think we're pretty secure against having odd people jump in. There is a possibility if they gave the VNC password to multiple people, that multiple people could see the driving screen. Hopefully they'd all be our people because we only gave the password out to people we like, and they would play nice and only one person drive. There is the possibility I thought about last night while I was trying to get to sleep. You see that iPad that's up at the top there? There's no reason why you couldn't attach multiple phones and stuff and have multiple Skype calls running along there. There's still only one person driving. There's no need to give the driving screen to everybody else just because they're on the screen, one of the phones. All in all, I was pretty happy with it. It's not very expensive to create. It's free to operate, and it behaves with only about 1.5 seconds latency. So the controls are not snappy, but fast enough.
What CPU are you using for it?
I'm sorry?
What kind of CPU are you using? What's your...
I have a Raspberry Pi that's connecting to the VNC and providing the desktop. The desktop GUI is programmed to Kinsvater, which is native to Raspberry Pi. And then the Raspberry Pi is connected through the serial port to the Arduino, which is responsible for the motors and the sensors.
That's what we did, but we used Raspberry Pi to the Parallax propeller board.
Yeah. So I let the Arduino do what it's good at, and I let the Raspberry Pi do what it's good at.
Yeah.
Okay, folks, we're right at time. So thank you.
Okay. I'm out of here, or at least back to just watching.
And John Jennings, you're up next with...
Here I am looking up. You take me off the screen so I can do what I need to do. Thank you.
Yep, there you go. And okay, you're up, John.
All right, thanks. Let me share my screen. So first I want to mention that I posted some reference notes in the chat that I'll be referencing during the presentation. So I thought I would share with you this robot that I've been working on for some time now. It's being built for the SRS PopCan Challenge. My plan is to show you the main components and then give a small demo of its abilities so far. And if there's time, I'll answer questions. But first, let's have a little bit about me. My first career was in the Navy, where I started off in damage control and firefighting, and ended up in the repair side on tenders and shore maintenance facilities. The picture of an old minesweeper I was on, and it was stationed in Tacoma. My second career was in collection development for Pierce College Library. You can see a picture of the library building I worked at. And I did the purchasing and cataloging for both campuses. But in both these jobs, what I enjoyed most was the creative side. And in the Navy and the college, I was given a lot of liberty on how I did my work, but the actual vision wasn't mine. And that's what I really love about a hobby. You have the complete autonomy. And as I've shared before, my introduction to robotics started with my photography hobby, and I got interested in doing stop action photography and designed and built my own equipment to capture images like the one you see here. I soon discovered that what I love about my robotics hobby is where there are so many different fields that you can dabble in. And I came up with my own ideas, design them in CAD, fabricate them, print them on a 3D printer, and all that stuff has made it so enjoyable. And that is the kind of experience I've had building RoboCame. RoboCame started off in June of 2017 when I purchased the TurtleBot 3 Burger. It was it first came out, and I got it as a means to learn ROS. And then in the same year, I saw the SRS PopCan competition, and I saw that one of the competitors were using the iRobot Create platform. That's the one on the right there. And that was the original TurtleBot. So I decided to do the same thing with my TurtleBot 3. And so RoboCame was born. Now, let's see. So Chaz already explained the competition and shared a link to the rules. I just wanted to add that there is also a private Facebook group where the other competitors discuss everything about the competition. It has a lot of good history in there about the competition. So I shared that in the reference notes. Let's see. So this is a picture of RoboCame as it is today. I have a link to its own web page in the reference notes as well that has more details on the build and how it evolved. But what I'm going to do is show you layer by layer what it looks like inside. So this is the bottom layer. Not much there. There is, I did decide to go with a ball caster where there had been a free moving Omni wheel as a caster before. I had to make some changes with the configuration of the wheels. And I could no longer have that Omni wheel there with this. This is the door opener here. So that's why I have this on here. This is a picture of the top half of the bottom. You can see the Dynamixel smart actuators These aren't the original that came with the TurtleBot burger, as I discovered those didn't have the radial load requirements I needed for this robot, which is now weighs 3 times as much as the original. You can see the mount for the ball caster over here.
This is great. All right.
Hello, somebody's got their mic on. Let's see.
I think I got it. Go ahead.
So you can also see the door opener here. And finally, the Raspberry Pi, which is running Ubuntu 20.04 and ROS Noetic. The middle section has an Arduino Nano that is connected to a Pixie 2 camera and light bar. The Nano gets object detection data from the Pixie 2 camera and publishes messages to a ROS topic on the location and width of the detected object. And the Nano also subscribes to a topic that controls the light bar. This section also has the OpenCR board by Robotics and a custom shield that controls all the actuators and gets all the inputs from the sensors. The shield also has, right in the middle, a buck converter that has an enable pin that I use to disable power to all the servos if I need to conserve battery. The bottom of the top layer holds the LiDAR to USB adapter board, a lower elevator limit switch, and the elevator servo. I chose to use a continuous rotation servo because it would be able to hold the elevator in any position with the power turned off without using any brakes. Okay. And then the top half of the top section, you can see the distance sensor, which monitors the height of the gripper elevator, and RP LiDAR, which isn't the original, it came with TurtleBot Burger. That one finally started wearing out, so I upgraded to this one. And a front bumper switch, which is used to stop the robot in order to engage the door opener. In the back of the robot, you can see the Pixie 2 camera with the light bar above it. The Pixie 2 can target several objects based on color, and it will report the coordinate and size of the object. Here you can see the gripper, which is designed to lock onto the can and then disengage power if needed. It uses 2 servos, one for gripping the can and one to operate the hinge to lift the can. You can also see the upper limit switch for the elevator, and there is a little tiny button right in the middle of the gripper that detects the pop can. And I think so. That is so in the process of learning ROS, I created several Python scripts to accomplish various tasks. And here's a list of them. So shortly, I'll be running a little 3-minute clip that has RoboCame running a little pick and place routine that I will narrate. My way of doing that routine is to run a bash script that runs all the Python scripts in a sequence or parallel, and that's, you can see the top half of that script there. So let me see if I can switch the screen to the video I want to share. Oops, what did I do wrong? Oh, there you guys are. I got something in front I can't see behind. Oh, okay. Here we go. Can you guys see it all right?
Yep, looks good.
Okay. So I'm going to start running this. So to begin with, RoboCame uses the ROS navigation to move to a map coordinate and pose. Okay, and next it will lower the gripper elevator to the bottom position. And then after that, it will turn on a light. And this is turned on in order to get lighting on the can inside what might be a dark fridge, and also kind of balance out the lighting. Start using the Pixie Cam to looking for the green color of the pop can. Once the button on the gripper is depressed, it stops that routine or that script. And next it will, close the gripper. The robot then will move a little so it can lift the can and then elevate it up above the LiDAR's view. Then it uses the LiDAR data to square the robot to the wall behind it. See it. And then next it will use the encoder data and dead reckoning to move to a certain distance forward, rotate 90 degrees, and start raising the elevator to the table height. And then it will move a certain distance away from the wall behind the table using the LiDAR data. Right there. And then it will move until the bumper switch on the gripper touches the table, and then lower the can, release the can, and then raise that gripper back. And then it uses the wall to kind of adjust and square the robot to that wall again. You can see it move. And then it heads towards the opposite wall and it monitors the distance with the LiDAR. And once it reaches there, it will stop and rotate 90 degrees. Well, first it adjusts itself again, then rotate 90 degrees, and then head towards that rear facing wall. And that's the end of the routine. There are a few upgrades I'd still like to do. Getting a certain smart speaker made by Amazon connected to ROS, so I can make and send voice commands. But the next major step to be successful in the Pop Can Challenge is to create a routine that does mainly 4 things. Opens the fridge door, grabs the can, closes the door, and finally localizes itself on the map in order to navigate to the next place, which is the living room table. And then at that point, I believe I'll have a real competitor. And that is RoboCame.
Okay, we got about 1 minute for questions, but after that, we'll jump into a 10-minute break. So go for it, folks.
I think the only thing that needs to be said is, wow, that one really works good.
I love the fact that you didn't go after a super complicated vision system, that it's just that Pixie, I think, is underrated in terms of what it can do. You know, just look for the color, center something of that color in the screen by turning left and right, and you know, you're lined up, you're good to go. You don't have to, you know, do a bunch of like object recognition on soda can with TensorFlow and, you know, all of this fancy stuff. Simple works, you know, and it's easier to debug.
Yeah, and there is a little issue that comes to mind, and that is sometimes if the lighting changes, the color changes. So that was one reason to have the light on the robot, but I still sometimes have to train it again to recognize the can.
So that's where structured light comes in so valuable. I'm still kind of blown away that people don't use the laser line trick, which is just where you have those laser levels that put out a laser line, and you just have that controlled from the robot. You take one frame with the laser on, take one frame with the laser off, you subtract the two, all the lighting variation drops out. And what you have then is a 3D distance to the object with the laser line.
That's clever.
Real super. Is somebody keeping count of the number of times that I've mentioned that? Sorry. I do tend to pound on it a bit. My apologies.
John?
Folks, I'm going to jump in for just a sec. I'm going to go ahead and start the timer, but and do it just exactly what we did for the last break. So folks keep talking, and we'll come back in 10 minutes, and we'll go from there. Thanks, folks.
John, I hope this means that like minds think alike, and I have success too. This is what I'm using to learn ROS, is the TurtleBot 3.
Oh, yes. That's what this one started off with. I ended up printing a whole bunch more of those plates to convert it into the waffle version.
Yeah, I bought this one to learn ROS because I saw you were using it. So you kind of inspired it.
Oh, cool. Yeah, I feel like I'm getting really close to actually, accomplishing the task.
Well, I'm going to use this other robot for the Pop Can Challenge, but I'm learning ROS with the TurtleBot. Makes it easier to do. I just use it in the house easily.
Yeah. On one of those links that I posted, the link to, because RoboCame has its own little web page. There are some older videos there with the same version you have that I use, that have it navigating the whole course. So you can check those out. It was once you get the navigation stack running and have that course mapped out, it seemed to be pretty easy.
Yeah, I saw you do it live with your TurtleBot, and that's what kind of inspired me to go that way to learn ROS. Because I think it's probably the best vision system out there.
Yeah, props for figuring out ROS. That's something that not a lot of people have accomplished. I pretty much failed in my attempts, but it's cool that you were able to get there. I'm really impressed.
I'll be more impressed with myself later on.
I'm impressed with anybody
well
who makes it through. I'm impressed with anybody who makes it through ROS. That's the documentation and the level of or the non-existent support and honestly the attitude of a lot of the people in the community just sort of blew me away when I tried to do it. So good on you.
So there was some challenges to begin with, because this is ROS 1, and one of the challenges when I discovered was when I took it to Robothon, because I needed a good network connection to my laptop through a router, and it was a big problem because of all the all the Wi-Fi devices that are there. It was it just had problems making a good connection and getting a good communication between the two.
Well, that brings up another question from me then. I was thinking of using the hotspot on my phone for my own Wi-Fi connection.
Here at home, what I ended up doing was getting a little portable router. And so what the router, what that little portable router does is it just grabs the internet connection from my home internet. But then it's, other than that, it's just using that router as its network. But it does need an internet. Unless you find another way of using, of getting a time synchronization between the laptop and the Raspberry Pi, it needs an internet to do that. At one point I was using a program that helped with that, so that the Raspberry Pi was getting its time from my laptop. What the heck was the name of that thing?
Were you?
Although I wasn't talking to myself.
Yeah, I don't know what that was. All of a sudden I noticed the connection just reset. So I think everything's good.
That was weird.
Actually, hang on. I don't think, nope, looks like all the participants are still here.
Yeah, mine dropped out and reset also. But I'm
First
back.
thing I noticed was that Carol was talking, but we couldn't hear her.
Yeah, that's what caught my eye as well. I think we're back. So carry on, folks, and we've got 4 minutes left on the break. So Zoom took a break as well. Fine.
So did you hear me talk about Crony?
No.
So that is a program I started using so that I could connect my laptop to the Raspberry Pi without an internet. What it does is it allows the Raspberry Pi to actually grab a timestamp from the time from the laptop instead of getting it from the internet. And that's what I tried using that at Robothon too, but I still had problems, and that's why why I was tethered. The last time at Robothon, I had my laptop tethered to the robot because I just couldn't get it to work.
Okay, but I think using a hotspot, that doesn't grab a public network. It's my own connection to the internet.
Yeah.
Yeah, and that would be true. The question is whether or not it would work any better in the morass of RF signals from other people's Wi-Fi. I mean, it might, but usually the thing to do to get Wi-Fi to work in a room full of Wi-Fi is to find a channel that isn't being used. And there's network tools and network people who are good at doing that. I'm not, but I've seen, I have had demonstrated to me, you know, like being on a convention floor and like firing up, you know, Wi-Fi connection to a robot and watching it just be actually struggling. And then one of my coworkers come over and go, oh yeah, hold on a second, let me check this. Oh yeah, it looks like channel, you know, 7 is good. Here, you know, tinker, 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 all of a sudden, bam, everything works perfectly. So that seems to be the answer to that. So, you know, it might work really well just because you happen to have a hotspot that works on a different channel than you know, one that isn't being used too horribly. But I was just kind of curious.
You're misunderstanding what I mean by a hotspot. On my iPhone, I have what's called a hotspot, which is its own Wi-Fi network using the cell phone system. So you're not on or sharing with anybody else.
Totally understand. However, you are still sharing the airwaves.
Yeah.
I mean, everybody is in
the same
position. So I was curious, John, what was the need for the Wi-Fi to the laptop? What was it? Is that how are you remote controlling this, or I'm confused?
So no, it's not remote control, but it does use the laptop to do some heavy lifting. It has all the visual stuff in there.
Oh, I see. So you're offloading that onto the laptop, which is then not placed on the robot. I gotcha.
Right. Yeah,
so that's how
it has an a Raspberry Pi 3 on there, which
right. That's how Shaky from SRI back in the 1970s worked. Mm-hmm. Really simple little computer on the actual robot, and then everything was offloaded to a mainframe that took up 3 rooms somewhere else in the building. It's nice to have laptops these days.
One idea I had was maybe just changing. I don't know, most people are using 2.4 gigahertz, and maybe just being able to switch to 5 if my router could do that.
Well, that's a great point. Yeah, absolutely.
That's actually what I'm in a condo, and that's actually what I do. Works great.
Oh, okay.
Phone's already 5 gigs, so I might be a step ahead there.
Oh, okay.
Okay, 3, 2, 1. Okay, so that's the signal. Next person up is James Newton, and I gotta get my notes up here. Let's see. You're talking about the Web-smart-phone-screen-blink-bot. So go for it.
I want extra props for such a wonderful name. So the name is ridiculous because I have a really hard time kind of explaining what this is. So I'm sharing my screen. Hopefully you guys are seeing that, this web page, Web-smart-phone-screen-blink-bot. But I'm also going to turn on video here in a minute and kind of switch back and forth between live and non-live. This old computer is really kind of dying here. So hopefully that will work okay. Are you seeing my screen share or no? Are you just seeing the camera?
Looks like it. Looks like you're good to go.
Okay, good. All right, great. Okay. So this is the Web-smart-phone-screen-blink-bot. Basically we're using secure web pages on a smartphone to safely is the key, drive a cheap robot with flashes of light using internal sensors and web services. So let me sum up. No, there is too much. 10 points if anybody gets the movie reference there. Basically, this is about how to avoid all the problems with the prior robots that I've made and allow us to safely use expensive smartphones to put brains on the robot, big time brains, and a whole sensor package with free online providers to host secure web pages that can gain access to phone sensors to control a very, very, very low cost robot for education and other stuff. The key then is that the phone has its Wi-Fi or even cellular network free to connect to web services for additional processing. So last year at Robothon, I'm going to go ahead and I think I'm going to stop sharing here, and because I just want you to focus on what's going on in the camera. I was sharing about these 2 robots back here. These are the San Diego Makers Guild made these low-cost cardboard robots, which are just using an ESP 8266 there, and then the newest version of it is using an ESP 32 here. And we made like hundreds of those and gave them out to kids. The idea here is that the ESP serves a web page, and then you connect to that web page with your smartphone, and then it can present any web page that you have loaded onto the ESP. And one of those will be a little control screen where you can drag your thumbs around, and it measures the position of your thumb and then transmits that information back to the ESP and tells the ESP to rotate the servos, and off you go, right? So it's really cheap. It's a $5 chip, a pair of $5 continuous rotation servos, a $2 battery pack, a little bit more if you do some extra niceties. There's a local company that made this guy right here, which is a custom board for it. I think you can buy that for $35 or something like that, with a cardboard laser cut body and the servos and the battery pack and all the rest of that stuff. So it's very clean, it's very responsive, it's a fun remote control experience. There's no app that you have to install because you're just using your web browser. And I'll post a link into the presentation that I'm giving right now in the chat. And from there, you can see some links to some stuff about it. But anyway, go back to last year's Robothon if you want to know more about it. So you can serve any static web page off of it. And there's actually an option to put an editor in one of those web pages so that your browser becomes a text editor that can edit the source code of the files on the ESP, so it becomes a mobile web dev platform. My idea was always that I would take the smartphone and then put it on the robot physically, and then I would have a web page on the smartphone being served from the ESP, and then the smartphone would then use its internal sensors and camera and all the rest of that stuff and send back commands to the robot. There's a problem with that. Number one, you cannot use the phone to connect to the internet then, because the phone is connected to the ESP. And worse than that, you cannot use the sensors in the phone from that web page that's served from the ESP, because it's not a secure web page. It's HTTP, not HTTPS. And all of the browser manufacturers have locked down access to the sensors unless the web page is secure. So I was crushed when I found that out. So that means you either have to write an app, or you have to install a certificate on the ESP, which turned out to be a nightmare, or you have to connect the ESP to your house Wi-Fi, which is very insecure and just a generally bad idea. Or you just have to live without the camera, mic, accelerometers, GPS, compass, and all the wonderful sensors that the phone can give you, right? Which is a huge loss, because they can tell the robot what's around it. They can sense that the robot is bumped into something. You can look at the accelerometers to see that there's a bump, right? You can use the compass to tell which direction it's moving, where it is. You could use GPS. You can use vision. You can use. There's so much on a phone that you're losing when you can't actually access the sensors on the phone. So what we want to do is leave the Wi-Fi and the cellular modem in the phone available to hook to the internet, right? To hook up to the internet, and pull the web page down from some online provider with a certificate, and then find some other way of communicating between the phone and the robot. So how can we do that? What are the ways that we can connect? So we could use BLE or Bluetooth, but honestly, they are both horrifically unreliable in my experience. Anytime somebody says radio or RF, I just immediately want to turn away from it. Also, it's just this thing about getting every model of phone to pair correctly is a nightmare. And on top of that, one of the issues is there's no way currently to send data from a web page to a BLE device. So you then would have to go back to writing an app again or something like that. I don't want people to have to install anything on their smartphone, because it's dad's smartphone or your expensive smartphone. And I see these robots that make you, install an app from China in order to control your robot. That just does not seem like a good idea. So anyway, Bluetooth audio, same problems. And then you have to decode audio on the robot. That isn't good. So then I thought about USB OTG, where you use the USB connection on the bottom of that. The first robotics people do that. The problem is that it's very poorly supported on the phone side. Many phones don't do it. So they've had to lock it down to a specific model of cell phone that does in fact support it correctly. And I don't want to do that because I want people to use whatever smartphone they have. Also, it's an electrical connection. So if a kid or some idiot like me wires it up wrong, dad's expensive smartphone can go up in smoke, maybe. And you also can't send data to USB serial from most browsers. So even if you could do it with USB OTG, who cares? Because then you still can't do it from a cell phone. One thing that I have seen, or from a web page rather, one thing that I have seen done is using the headphone jack. And that actually is kind of a fun thing. You can have a web page generate sound, and the sound then goes out the headphone jack and directly drives a pair of servos. So that's a fun little trick. But not all phones have a headphone jack, and it's relatively minor, but still it's an electrical wrist. But you know what all phones do have? Every single phone out there has one of these, and it can't be blocked, and it conveys more information than any other single method of connecting to the cell phone. And it doesn't require any permissions or anything like that to access. And what that thing is a screen. Ta-da! We have a solution to our problem. Isn't that wonderful? So what we're going to do is just build a circuit that senses light. And the web page can then blink out messages. You may have noticed that running right there. And you can do it at very high frame rates these days, right? So minimum 24 frames per second, which is, you know, like maybe a byte per second or a couple of bytes per second. But I've actually found that, you know, they run much faster than that. You can transfer a large amount of data in a small amount of time. And if you need more, you just add more sensors. So you go in parallel, right? So right now what I'm doing is just clock and data. So that's the clock on the left and that's the data on the right. This third block over here is actually a latch. So there's no reason why it couldn't actually be hooked up to a shift register. And then you don't even have to use a microcontroller. I haven't played around with that, but that's within the possibility. I have verified through a couple of friends who are better at electronics than I am that this does in fact work and can work more than quickly enough. It is not blazingly fast, but it, you know, is good enough to be able to send like a how fast do you want the left motor to go, how fast do you want the right motor to go, kind of a signal. So what that means is that we can write a web page, for example, host it on github.com, which hosts static web pages for non-commercial use, absolutely for free. And because it has a certificate, it's an HTTPS web page, it can access all your phone sensors. Also, I found out that it sets access control allow origin to star. So that means that your web page that's being hosted on github.com can reach out to any third-party service like Google or whatever to get extra data. Then we blink out the message to a really low-end processor like an Arduino Uno. I know this may look a little bit confusing, but this is an Uno underneath here. And this is a Dynamixel servo shield that I have on here just because I'm working on another project with the same setup. But the pins just come straight up. So these light sensors are hooked into the same pins. In the JavaScript on the page, you get access to all the phone sensors to control the robot locally. You can send data to cloud services for deeper analysis. And there's a system called Bosch, B-O-S-H, which can transfer data for us for free to any terminal on the net. There's a link here to how Bosch works. It is absolutely unblockable. It is absolutely reliable, and you can host it for free. So basically, Bosch supports server push notifications. So that allows you to have a two-way conversation between the server and the device. By simply, the way it works is the smartphone, for example, would make a request of a server, and the server simply doesn't respond to the request. And what that does is that keeps that connection alive, and it'll stay alive for about 30 seconds before it dies, before it times out. So if you've ever connected to a web page and you see the little thingy spinning and it's waiting and it's waiting and it's waiting, and then all of a sudden the data comes down, it's basically the same thing. So the point here is that now you have an open connection that's pending for data from the server to the peripheral, to the smartphone. And then the server gets a connection from another device like your PC, for example. And from your PC, you send a message to the server saying, hey, tell the smartphone this. And at that instant, the server goes and looks and goes, oh yeah, I have a request pending from that smartphone. And then it sends the data down to the smartphone, which then closes the request. And the smartphone web page then immediately turns around and makes another request of the server. So anyway, I've pasted a link in there about what Bosch is. Thank you, Lloyd. So you get free teleoperation. You can also do vision. You can use the camera. I don't know if you can see this, but there's a tiny little screen right there, which is the actual view from the camera of this smartphone. And when I move my hand in front of it, it's detecting the motion of my hand, and it's changing the signal that's being blinked out through the bottom there. There's an example of this, this is the page that's running on the actual robot right now. And it kind of demonstrates how that works. So optical flow is a possibility. We can use the accelerometer to detect when we have bumped into something. You can use the compass. You can do facial tracking with opencv.js, which will run in a browser and do face detection. We can look for voice commands using the web speech API through an external provider. We can access GPS. All of that's 20 bucks worth of parts. So all you need is the light sensors, the headers, the servos, some power for the servos, no electrical connections to the smartphone, and maybe some LEDs for a laser line driver or indication or something like that. This little printed circuit board that I made makes connecting servos super, super simple to a microcontroller. There's a link to that in the project description as well. And I guess what I will do now is stop that, share screen again. Make sure I get the right screen. And let's move on to the live demo section here. This is from the Arduino IDE. This is actually showing you the signals that I was getting, or just a few minutes ago. I've stopped it so that you can kind of view it. The blue trace right here is the clock signal. And I just want to be clear, these sensors that I'm using, all I have plugged into the Arduino is these little light sensitive resistors. I mean, these are absolute garbage components. And I'm using the pull-up resistor on the Arduino to provide the pull-up on it. So the total external hardware is just one of these sensors plugged in between ground and one of the analog pins on the Arduino. That's all the wiring that's actually required for the input. And then you have to hook up to the servo somehow. But you can see the clock signal that I'm getting here on the blue trace. The red trace is the data signal. This green trace is the automatic gain control, and that actually drifts up and down in order to compensate for light levels. I'm doing that programmatically. You notice that the green line bumps up a little bit when this comes down. That's hysteresis that I'm introducing. And then down here on the bottom, you can see the actual decoded signals for clock and all of that. Let's codes down here, but I'm not going to bother with that right now. Let's go live, and you can see the actual data that's coming across from it right now. You'll notice that if I push down on that data connector so that it gets a little bit lower, you can actually see the gain shifting in order to find the center of the signal. Okay, so anyway, that's good enough for right now. I'll go ahead and stop sharing. And I think I'm probably out of time, but one thing I want to say in the end here is I do not have time to continue pursuing this. I literally wrote this Arduino code this morning, getting ready for this presentation. So it's the sort of thing where I really hope other people will take this and go further with it, because like I said, I'm not going to have time to. So thank you.
Okay, thanks. Excuse me. Thanks, James. Next up, we have Donna Smith with her robot build bucket list. Let me switch the video here. Oh, where are you, Donna? I'm not seeing.
Oh, yeah, I'm still on. I'll ask you to pin me, please.
Yeah, that's what I'm trying to do. I can't find. There you are. There you go. Okay,
Okay,
all
great.
set.
Thank you. Now, the first thing I'm going to do is share screen here. Let's see. Okay, can everyone see my slides there? Okay, are my slides showing everyone?
Yes.
Yep, we can see them.
Okay, great. All right, hey, thank you, Lloyd, and good afternoon, everyone. Today I'm going to talk about my bucket list of projects. So besides reviewing some robot build interest areas that I am currently pursuing, I want to impart some advice, some points of reference as far as research that I've done, and give some general information and hopefully saving, at least time-saving advice that I have gleaned over time. What I'm going to do is, when I'm done today, is I'm going to provide in the chat a reference handout sheet for everyone as far as some specific URL links for your after this event reference to utilize. And what I'm going to do today is not just as a time-saving point. I'm not going to actually show during my presentation the actual robots themselves as far as like a camera view or video. I'm just going to be mostly talking to you. And then at the end of today, during the networking session, I can actually show any camera views for people who are interested. Okay, so for me as a robotic hobbyist, part of the high level of fun that I get from this hobby is being able to learn and experiment, try new things, learn new technology, just like all of us do here. But one of my favorite routes to actually do that is to actually build robots for a specific contest event. And that's either for my own contests that I run solo, or as for ones that are being hosted either in person or remotely by clubs that I participate with. So the first project I want to talk about today is for a contest that I'm building that is very similar to the SRS Robo Magellan. And that is being hosted by the Dallas Robotics Group, and the contest is called Robo Columbus. And the specifics as far as the platform that I have chosen, I've chosen a relatively easy plug and play, kind of cheap, large scale RC truck. It's a Tyco brand name truck, and it just has one rear drive motor, and it has one mega size front steering motor. So that is the way that the platform itself is controlled. This is not a four-wheel drive truck, nor does it have proportional steering. So it's a great car steering type platform to get started with. The main processor board, I'm for the processing power on this, I have a main control board, and then I am building a distributed multi-processing network to offload a lot of the CPU-bound intensive sensor and processing functions off to other dedicated boards. Now, the main processor board that I have chosen is an Arduino Mega 2560, and that houses the overall control logic code. Another primary controller board that I'm using specific for vision processing is to utilize a Raspberry Pi 3, utilizing the Pi camera version 2. And that is going to, all this is still being developed, but that is going to handle the orange cone detection and hopefully eventually object avoidance and overall environment sensing in a vision-based fashion. Other specific control boards and sensors that I am employing is for that single drive motor. I'm utilizing a Parallax HB25 controller, And then for that steering servo, I am using a Pololu Mastro servo controller, specifically part number 1350. And then to enable navigation, I am utilizing a GPS receiver as well as IMU. I have a Parallax, this is quite a few years old. I have a Parallax 28500 for the receiver that I am doing my initial build with. And for IMU, I am using a Pololu part number 2739. And the IMU will be primarily used for getting accurate heading information, with the balance mostly of the navigation data coming from GPS and maybe from other methods such as dead reckoning. So that's still being developed. And this platform, this Tyco truck, has a generous, very customizable front bumper area. And so I am in the process of building a front bumper ring for various impact and distance sensors strategically placed, say for instance, the parallax ping and sharp sensors, that type of thing, to help with distance for in-front object detection. The overall Arduino Mega software architecture that I am developing utilizes subsumption or behavior-based design. And also, to help save my back with this larger robot, I have decided to implement utilizing a standard RC control system. I have decided to implement a user switchable RC control versus autonomous control, along with a fail-safe mechanism embedded in that whole network. And so I'm currently working on that. The ultimate goal of this build is to compete with it in the upcoming November 2022 DPRG Robo Columbus competition. I will be a remote entrant for that. So that is my immediate goal for that project. The second project I want to talk about today is dedicated to the SRS Robo Magellan entry that I'm currently working on. And the platform of choice for that one is I have chosen a more expensive base for that. One that is directly designed for a varied outdoor terrain environment. And that is a Traxxas RC truck, specifically the Emax truck. And it has proportional steering, but it's not four-wheel drive. And what I love about this platform is it's hackable. It is a perfect RC truck base to be hacked. And it out of the box, on top of that, it comes with a whole bunch of RC components that you can plug and play and easily. It also has ample space once you take the top off. It has ample space for stackable decks for your various sensors and etc. And it has a built-in area for your battery packs. So it's a really cool out-of-the-box solution for a outdoor rover build. Now, I am taking a different approach with this robot as far as the primary computer capability and also the vision solution. The primary computer board that I have chosen is a small footprint PC that is not in a regular PC case. And I have chosen a VIA EPIA Mini ITX computer board. This is a piece of technology that is quite a few years old. And I come from a engineering background as far as directly controlling and programming Intel PCs. And so this was an easy out-of-the-box solution to enable direct programming in an embedded environment. This board is an Intel x86 architecture, and so you can utilize standard PC software toolchain to program it. You can run either Windows or Linux. My choice is Windows XP Pro Service Pack 3. I'll explain why in a minute. And the hard drive is swappable. It's swappable with a compact flash card, where in my case, I'm utilizing a 4 GB compact flash. And what's so nice about this during the development cycle is, depending on your OS or your development tools, whatever, you can easily swap out to a different hard drive to help with your development tasks. And it's easy to run in a headless fashion. In other words, where you complete your programming and all your sensors are hooked up, the computer live is powered on, it starts running the executable that is self-launched upon power up. And that's what the headless has to do with. You can also directly program this, though, directly on board, which is what I'm doing with it to program it, where you directly connect a monitor and keyboard and mouse. You don't need to do the traditional host and target embedded programming methodology with this board. So it's really nice that way. And I had mentioned about the unique vision, computer vision solution I'm doing. So I decided to use a standard USB webcam and utilizing a software package called RoboRealm. Now, RoboRealm requires a Windows operating system. Therefore, why the Windows XP? And I have a copy of RoboRealm that is several years old. And the maximum Windows operating system that it will run in is Windows XP. And so that's why I chose that approach. It is currently quite a pricey package, but it might be worth it if you want to deploy a solution for a robot like what I'm doing. It has 2 license types available, along with a 15-day trial period. So you are free to really experiment with it and try and get something great out of that 15-day trial. What I like about RoboRealm is it offers a set of out-of-the-box OpenCV type image recognition algorithms and subsystems that you can assemble into a script that you build within the RoboRealm environment. And you assemble that script and build out your pipeline. That pipeline is a RoboRealm specific term. And that pipeline executes automatically when the application is run, the RoboRealm application. You can also run that in a faceless fashion, where you have a defined script, but yet it is controlled through a different control source. In other words, like a C or C++ executable, that calls into this script via the API calls that are provided in RoboRealm. So it's very, very flexible. And the package also includes a huge set of robotics-based modules. Modules is another RoboRealm term. And it's a huge pool of these modules. Say, for instance, object recognition, where you can actually, via a neural network, train your module to recognize a specific type of image. So that's a key there. It also has shape matching modules and direct integration with your GPS receiver. They have a module called GPS Reader for things like that. Okay, and then on to project number 3 for my SRS line maze entry. So what I'm doing there is the platform of choice is a parallax activity bot or BoBot with a couple of slight modifications that I've made. One of those modifications has to do with the rear balancing wheel. I don't like the default plastic ball that comes with the platform that you put together. Instead, what I did was I came up with my own custom mount bracket, and I installed a Pololu ball caster with 1/2-inch metal ball, and specifically Pololu part number 953. And that, when I have all that installed, it allows for a real smooth maze running navigation with the layout of the course, and it allows for easy full spin in place or easy left and right turns. It's not a clunky design any longer. So that was one modification I did. The other is that I swapped out the main processor board that comes default in the kit. I have switched to an Arduino Mega 2560. And the reason why I did that has to do with the more traditional computer science maze solving algorithm that I want to deploy on this build, where I need a lot of SRAM or dynamic RAM to utilize to execute this algorithm. So I found a couple of build it yourself, relatively cheap, SRAM expandable memory shield that is compatible with the Arduino Mega. And you can either, with those projects, you can either build out a 32K or a 512K memory expansion shield that can directly interface with that Mega. And that will allow me to build out this complex maze search algorithm. What I'm thinking about is implementing either an A-star or a D-star algorithm. Okay. Now, so on to some overall guidance or points of view that I wanted to share.
Hey, Donna?
Yes.
I just wanted to pop in real quick because you're at time. So how much time do we got?
Okay, yeah, just maybe 2 minutes more. Okay. All right, so rather than reinventing the wheel, I know that we as engineers and hobbyists love to come up with our own creations. Well, I have found through trial and error that it's best to base your guidance and your reference materials utilizing reliable web sources. And one of my favorites is to find projects specific to what I'm working on, utilizing Instructables.com or code repositories that are on GitHub. So that's a recommendation I have for you. Point number 2, find ready-made solutions for skill areas that you're lacking. For me, that is mechanical design and construction. So I start with off-the-shelf platforms that fit my requirements and budget needs and go from there. And then the last point I wanted to make is to do with the RoboRealm software package. If you do decide to purchase it, be wary of something with the way that they've got their documentation set on their website. All they do with their documentation set is continually update that to match the current version that is currently for sale. So if you purchase, I recommend that you do a website crawl capture, create your own static copy of that website documentation set that fits what you currently have. Otherwise, at some future date, you might find something on their website, a feature that you don't even have or that isn't implemented the same way that you have it. So for your particular version. So with that, I will be wrapping up, and I want to say thank you. And perhaps we've got time for a couple of questions from the audience. And as I said, I will upload that document that I mentioned.
Okay. Well, let's see. We can do a couple things here actually, because Donna was basically our last presenter. So we can run the. How long do you want to run the recording for, Donna? For a little bit longer, close down?
Yeah, yeah, let's see. So I did have, let's see, for some reason or other, I'm having troubles. Here we go. I did want to make, whenever you were done with your portions, Lloyd, I did want to just provide a little bit of other feedback regarding this event today. But, you know, whenever you're ready for that.
Okay. Well, my single closing remark is thank you, Donna, for actually organizing all this. I don't know if everybody knows. I was kind of running it, but Donna did all the legwork in the background and stuff, working with the presenters and stuff. So thank you for doing that, Donna. And then I was just going to hand it over because you had a couple closing remarks. And I guess after that, we can just turn it over to open chat. And
okay. Sounds good. Okay. So as Lloyd mentioned, I was the organizer for this event. And first of all, I want to thank everyone, both the attendees and the great set of presenters today, and also Lloyd and everyone at the SRS team and DPRG team to help make this a fantastic event. I know myself, I really enjoyed it. I learned a ton, and as always, when it's something to do about robotics, I always enjoy myself. So I really enjoyed it, and I hope everyone else did as well. I would like to either now or during the upcoming networking / follow-up portion of this event today, I would like to ask for any feedback as far as commentary for, you know, how to improve the next SRS online event, or what you liked, what you didn't like, and what you'd like to have changed. And, you know, how also to do with the spectators, if people would like to comment as far as how they found out about the event, that would help for next time for our advertising methods to find out how to best reach people. So again, in wrap-up conclusion, I want to thank everyone, and I really enjoyed helping to organizing this, and everyone for everyone's assistance in this. And again, thank you very much.
Okay, folks, so what I'm going to do now is I'll stop the video, but folks can hang out as long as they want. Yeah, just do general chat. So let's see, hang on.